So here's a transistor, and we can look at it just like a switch. Let's change the gate voltage. Let's change it to, let's say, 0 volts. We can see that there's no current going through drain or source, or from the higher potential to lower. Now, let's change it back to 5 volts. And we can see there's current going through this path. At this moment, the current is 122 milliamps, or 0.12 amps. So, let's increase the voltage. Let's put it to 50 volts. Apply, and we can see it's 4.6 amps. Depending on the occasion, it might be okay, it might not be okay. And we can see that we can pass the current through the transistor. So now to the switch analogy. I shall copy paste this part and replace the transistor with the switch. So when I replace it with the switch, I would have to add a resistor, because this simulator is an ideal simulator, and this path here has no resistance, therefore it's short circuit. So I shall add a small 1 ohm resistor. To simulate the circuit resistance. So let's take a look at it. When I apply voltage, the transistor lets the current pass through it. When I take the voltage off, like that. Right now it's in the air, but we could look at it as 0 volts. At least that's what the properties are showing here. And if I, let's say, take that off, then it'll apply here as well. We can see there's no current. There's some current in here, but virtually we could call it no current. There's one more thing that we should look at it. I could have 50 volts over here, or I could have 5 volts. There's still current, but the current changes. So in that sense, the transistor is not a switch, but a transforming resistance. In a way, we could call it that. I suppose that's where the name comes from. But we're looking at it as a switch. So let's apply some different voltages over here. Let's lose the ground and use another voltage source over here. So the current cannot flow from here to here because they have the same potential. But let's say that I change the potentials. Let's put it to 50 volts over here. So we have about half a microamp over here. But we don't have that huge current going through here, like in milliamps that we had before. So why is that? I have voltage over here. The switch should be closed, but it's not. That is because the potential over here has to be higher than the potential over here, or the gate potential should be higher than the source potential. How much higher is defined by the threshold voltage. This transistor has the threshold voltage of 1.5 volts. So let's up it 1.5 volts Let's put it to 6.5 volts. Nothing changed. We can see the amperage is the same. Let's put it a little bit higher, 6.6 volts. And we can already see the amperage went up. So if I up it a little bit more, like up to 10 volts, we have the same outcome that we had before. When we have 5 volts here, 0 volts here as ground, and 5 volts here, we had 122 milliamps current passing through it. Now, this is the N-channel transistor, but we also have a P-channel transistor. So let's look at that as well. I shall copy paste this one and put it over here and change the transistor to the P-channel transistor. And let's run the schematic once again. We can see that the current passing through is huge. Now why is that? That's because the source voltage is up here and the drain is down here. If we look at the schematic, we can see that the source and drain have switched their places. They don't have to, but usually the source is up here and the drain is down here. Why is that? Usually when schematics are drawn, the higher potential is up, the lower potential is down, and other potentials are in between. Sounds logical. And the arrow on the transistor shows the way the current should pass through that transistor. So it should pass from here through here, like that. And in this case, from here to here. I shall also name it. Edit and name it. So this is the P-channel transistor. Now, as it was in here, the gate voltage was supposed to be 1.5 volts higher than the source voltage. So in here, the source is higher, is upper, so the source voltage should be a threshold voltage higher than the gate voltage. So if the threshold voltage here is also 1.5 volts, which it is, then to get the same current, we need the potential differential to be the same as in here. So in here it's 5 volts, then in here it also should be 5 volts. So let's put it to 45 volts. And run the circuit. We can see the current is exactly the same. So the N-channel transistor, we could look at it as a normally open. If we don't apply any voltage, it is normally open. If we apply voltage, it is closed. It conducts. And the P-channel transistor is normally open. If we don't apply any voltage, we get quote unquote low resistance, high conductivity, and if we apply voltage, let's say 50 volts, we can see it acts as an open circuit, sorta. We can see there's some nanoamps going through, but ideally it would be an open circuit. Thanks for watching.